tonight we have with us Mr. Spike Psarris. For those of you that know me and have been part of the Creation Society since the beginning, we've been trying to get Spike here since our first year in existence, which was about 5 years ago. So we're really happy that he's been able to be with us, that he's able to be with us tonight. So Spike is a former engineer in the U.S. military space program. He entered that role as an atheist and an evolutionist. He left it as a creationist and a Christian. And he now speaks and writes on science and biblical creation with an emphasis on astronomy and cosmology, and has produced a 3-volume video series entitled What You Aren't Being Told About Astronomy. He also has a website called creationastronomy.com. So let's welcome Spike tonight. I know you're really going to enjoy this.
Thank you, everyone. It's my privilege to be here. Grateful for the opportunity. Boy, astronomy and cosmology, big subjects. Many things we can talk about. Our chosen topic this evening is our Goldilocks cosmos. Now, what exactly that means, we'll talk about in just a moment. I want to answer a question first that some of you might be having. You might be wondering, are you actually in the right place? Because if you saw the promotional flyer, you were expecting this guy, and instead you got me. Well, this is me before COVID closed all the barbershops, and this is me after, when you got big matters in your own hands. So that's what the discrepancy came from. Just in case you're wondering. So my background is in military space operations, and I like to mention that at the beginning of my talk because people wonder, why is the speaker here? Why is this topic a passion for them? I was indeed an atheist and an evolutionist when I first entered that role as an engineer, and I was an atheist because I was an evolutionist. I understood that science showed that there was no God, that we all came from apes, the universe itself came from the Big Bang, etc. So if science removes the need for a God, why would you want to believe in one anyway? And it wasn't until being confronted with evidence against my evolutionism and my atheism that I started to struggle with some of these issues. And after trying to disprove a lot of this stuff for basically almost a year, that I was confronted with a choice. I either had to continue my own beliefs, which I now knew were not supported by the evidence, or I had to adopt new beliefs, which I had been trying to disprove this whole time. So I did indeed become a creationist and a Christian, and the transformation happened in that order. I essentially became a creationist first because of the evidence, and then that opened the door to becoming a Christian afterwards. And I like to mention that when I speak because a lot of times in the creation evolution issue, the other side of this debate will say, you Christians are creationists because the Bible requires you to be. Because you put on these blinders due to your faith, and so you don't see all the scientific evidence. And if you just take off the blinders, then you would see all the scientific evidence for the millions of years and evolutionary processes and so on. Well, I'm one of many for whom the opposite was true. I was convinced by the evidence first that creation was a true account of history, and then that opened the door to becoming a Christian. And I say open the door because becoming a creationist is not sufficient to make one a Christian, because that's the work of the Holy Spirit, right? I mean, there are Muslims who believe in creation. But nevertheless, this is a stumbling block for many, as it was for me. And so that's why I speak on it today. And our chosen subject tonight is our Goldilocks cosmos. What does that mean? Well, you may be familiar with the story of Goldilocks and the 3 bears. Papa Bear had something that was one extreme, and Mama Bear had something that was the other extreme. And the baby bear's thing was always just right. Well, this same term has been applied to the entire universe. Is my audio cutting in and out, by the way? It sounds like it is for me.
Turn your head.
When I turn my head? Don't turn the head, okay. We can look at the cosmos and ask the question, does this look like the outcome of random processes? Or does it look designed? And we can look at this at multiple levels. I don't think I turned my head then. Should I use the handheld? Is that maybe?
Maybe so.
Yeah.
Yeah, I think so.
Okay.
Pardon the interruption. There, hopefully this will be more consistent. So we can look at the Earth and we can ask, does this look like the outcome of random processes, natural processes operating according to the laws of physics? Or does it look designed? We can ask the same question for other objects in our solar system. We can look farther out and look at the Milky Way galaxy itself that our solar system is within. And of course the Milky Way is within the universe to give us the biggest context of all. And for each of these levels, we can ask the question, does this look random, like the outcome of random processes, natural processes, or does it look designed? Now, as Christians, we would affirm that yes, it was designed because the Bible says that we live in a created universe. Genesis 1 says, in the beginning, God created the heavens and the earth. However, our society, by and large, tells us that we are not allowed to use this as an explanation for the universe that we live in. Why is that? Because this is a supernatural explanation. Now, the prefix super means that which is above or beyond. Thus, the supernatural is something which is above or beyond or outside of the natural world that we can see. And we are told that the only allowable outlook is naturalism, that we can only invoke natural processes to explain the things that we see around us. Well, the Bible says that the cosmos was created for multiple different reasons. The various objects within it are meant to provide signs and seasons, to sustain life on earth, and to declare God's glory. On the other hand, the non-creation viewpoint would deny that there is a purpose behind this at all. Nevertheless, the cosmos does look designed and finely tuned, as we will see. And even many secular scientists recognize this. These are books, this book in particular is written by secular scientists who are certainly not creationists, who acknowledge that the Earth has a long list of characteristics that make it very rare, and indeed we might expect to never find such a similar place as our planet anywhere else in the cosmos. This book too makes similar arguments. However, even people talking about this from a secular perspective don't go far enough in their thinking. And what we're going to do tonight is take the secular view to its logical conclusion. We're going to say, well, if that's true, then that also implies this other thing that perhaps the other side doesn't want to talk about. So, in order to do all that, we have to know exactly how the other side views things. So, we're told that in the beginning, there was a quantum fluctuation of the vacuum, and our universe leapt into existence. This is now called the Big Bang, of course. Here's a little animation of that. Supposedly, there's a fluctuation which produced energy, which cooled and formed matter. The matter gathered into stars, the stars gathered into galaxies. Inside of that, there were gas clouds forming planets, and here we are billions of years later looking at it all. Well, this, at the very forefront of this story, has as its origin a fluctuation of nothing. There was nothing, and then there was everything. The everything then turned into the Big Bang, which, as I just described, eventually formed all the other things we see, including the Earth and the solar system within which we reside. More specifically, our solar system supposedly came from a solar nebula. Nebula means a big gas cloud. So suppose that there's a big cloud of gas, which cooled and formed dust, which formed rocks, which formed planets, etc. And there's a lot of details here I'm glossing over, of course. The Earth is within a distance from the Sun called the habitable zone, and this supposedly explains why we're able to live here. So what is the habitable zone? Well, you can imagine that if such a thing had happened, that we came from this cloud of gas, close in the middle is where the Sun was forming. It was very hot there. A planet forming here would not be able to have liquid water on it because the water would just have the steam. Water vapor. Conversely, if you're too far away from the Sun, it would be too cold. Water would be frozen as ice. You couldn't have life there either. But the Earth is in that little Goldilocks zone right in the middle where liquid water is possible. It's not too hot and it's not too cold. Which is why they call this the habitable zone, this narrow distance from the Sun within which liquid water is possible. Now, if you follow astronomy and you're interested in this kind of thing, you'll frequently hear mention of, well, we just found another planet in some other solar system, and it's within the habitable zone of that star, so maybe there's life there. No doubt, you've heard some of this. Well, is being in the habitable zone enough to support life? It's necessary to support life, but there's a long list of other things necessary for life as well. There are things right in our own solar system that are within the habitable zone. For example, the moon. Is the moon a good place to live? No, of course not. But the moon's in the habitable zone. My point is that when you hear words like habitable zone, there's been a lot of overselling going on. You need to be in the habitable zone to support life, but you need a long list of other things as well that are often not talked about. And something that is also not generally talked about is the fact that had the solar system come from a solar nebula, although the Earth is at the proper distance to have water, the solar nebula couldn't have made any here. Because in the initial parts of this model, conditions would have been too hot, even here where the Earth is. Water could not have condensed from the nebula at our distance from the sun. So my point in this little excursion here is that when you hear habitable zone, yes, that's necessary for life, but there's a lot of other things as well. And even being in the habitable zone doesn't mean that you necessarily have water to begin with. That solar nebula model actually says the Earth shouldn't have water on it at all today, but of course it does. Moving onwards. The Earth, you can argue, is uniquely designed for life in a long list of characteristics. For example, we have a magnetic field, a magnetosphere. This protects the Earth's atmosphere from being stripped away by radiation from the sun. Of course, if our atmosphere was stripped away, that would be very bad for life on Earth, but we have this nice protective magnetic field to prevent that from happening. Our rotation period. 24 hours it takes the Earth to rotate around on its axis once. Now we tend not to think about this, right? I mean, that's how long a day is. And very few people wake up in the morning thanking the Lord that He made the day 24 hours long. It's just how it is, right? Well, no, 24 hours is not this inevitable default value for a planet to have as the length of its day. Even in our own solar system, we see very different values for this. For example, Jupiter has a day just 10 hours long. Imagine how quickly this planet is rotating to make it all the way around once in just 10 hours. Well, if the Earth had something like this, we would have very violent winds on our surface. Would not be a very pleasant place to be. On the other hand, if the Earth were much slower in its rotation rate, that would give us other problems. We would have one side exposed to the sun's radiation for longer, and then on the night side for longer, so you'd have much more pronounced temperature swings. We see, again, in the solar system, planets that rotate more slowly than the Earth. Venus takes 243 Earth days to go around its axis once. So hopefully you see my point here. 24 hours for us is just right. It's a Goldilocks value. We get just enough radiation from the sun, warmth spread evenly across the surface of our planet without having the violent winds and such that a more pronounced rotation rate would give us. What else do we see about the Earth? Well, our axial tilt is 23.5 degrees. So if you imagine all the planets lining up with the sun this way, the Earth's north pole is not straight up and down relative to that plane. It's actually tilted over by 23.5. This gives us very moderate seasons. Again, we tend to take this for granted. We don't think about this because that's just how it is. But even, again, looking elsewhere in the solar system, we see that that's not necessarily a default value. Mercury has basically no axial tilt at all. It's only 0.01 degrees. If the Earth were like this, well, we wouldn't have seasons. And the poles would be very different in their climate compared to the equatorial region. On the opposite extreme, we see the planet Uranus, which is actually tilted way over on its side, more than 90 degrees. Other planets spin like tops as they go around the sun, but Uranus rolls along sideways like a ball. That means that for a good part of its orbit, one pole is pointed at the sun continuously, while the other side doesn't get warmth at all from the sun for, again, a good part of its orbit. If the Earth were anything like this, we would have very violent temperature swings from season to season. But we don't have any of that because we have this Goldilocks value of 23.5 degrees for our axial tilt, which is just right. The Earth's orbit is circular around the sun. It's not quite a perfect circle, but it's close. That means we get an even amount of warmth from the sun as the year goes by, because it takes us 1 year to go all the way around, right? Again, this is not necessarily a default thing for planets to have. For example, Mercury has a more elliptical orbit, like you see here. It receives twice as much radiation from the sun at its closest point compared to its farthest point. So imagine how different life would be on Earth, or impossible for that matter, if during the summer we received twice as much heat from the sun as we did during the wintertime. But that's not what happens here, is it? Now we do have some slight variations because of the axial tilt, but the amount of warmth that the Earth overall receives from the sun varies very little over the course of a year. Our atmosphere is not too thick and not too thin, it's just right. You can model the Earth's atmosphere as being roughly the same thickness, the same relative thickness, as the skin of a peach. You know, think about how thick the skin is compared to the peach itself. That's about how thin the Earth's atmosphere is. Our atmosphere really isn't that thick. I mean, if you could drive at highway speed, straight up, you'd be in space in a couple of hours. I mean, think about how hostile an environment space is. It's not that far away from us down here on the surface. Yet we don't have a hostile environment here. Why is that? Because this atmosphere, A, protects us from radiation from space, and B, gives us air to breathe. Now, if it were much thicker than the atmosphere we have, or if it had a different chemical composition, we would have a massive greenhouse effect like Venus has. Venus is very similar to Earth in its size and mass, but it's very different than Earth on the surface. The atmospheric pressure is 92 times that of Earth. Standing on the surface of Venus, you experience the same pressure as being 3,000 feet under the ocean on Earth. And the surface temperature is almost 900 degrees Fahrenheit. Horrible place to try to have life, right? Impossible. But we don't have this type of problem on Earth because our atmosphere, again, is just right. On the other hand, if our atmosphere was much thinner than it was, then we might have a problem like Mars has. Its atmosphere is too thin to be able to retain liquid water. Even though it's cold on Mars, the boiling point of water is very low because the atmosphere is so thin, and so a puddle of water on Mars will boil away fairly quickly. But the Earth doesn't have these problems. It's not a greenhouse place like Venus, and it's not a desert planet like Mars is, because our atmosphere is just right, the Goldilocks value. So we can look at all this and we can say, does this look like the outcome of random processes? All these different things within a very narrow margin of error, really, to produce such a nice habitat for us here on Earth. Well, I think it's clear that the Earth was designed for life, and as Christians, this shouldn't surprise us anyway, because the Bible says that the Lord made the Earth for this purpose. For thus saith the Lord that created the heavens, God himself formed the earth and made it. He has established it and created it not in vain. He formed it to be what? Inhabited. So if an omniscient, omnipotent, and benevolent creator made the earth as a nice place for us to live, then we shouldn't be surprised that that's exactly what it is. There's more more time we could spend just talking about the earth, but I want to move on to other subjects. Looking a little bit farther out, we see the moon. Now, how many people have asked the question, is there evidence for intelligent design of the moon? I mean, this is something most people don't talk about. But you can argue that there's a lot of reasons to believe that the moon isn't uniquely designed to support life on Earth. For example, the moon is about 400 times smaller than the sun is, but it's 400 times closer to us than the sun is, which means that from our perspective, the moon and the sun look about the same size. So at certain times, when the moon passes in between the Earth and the sun, it can perfectly block out the sun, and we get a solar eclipse. So it's uniquely positioned for this. There's over 200 moons throughout the solar system. How many of them have the exact combination of relative size, distance, and position to produce these sorts of events for observers on the surface? And the answer is one, our moon. Out of these 200 moons, ours is the only one. Now, it's very interesting. It's an amazing coincidence, if you're coming at this from a random perspective, that the only place where it's possible to observe these events is also the only place where there are observers to see them. The Bible says the moon was meant for signs and seasons, among other things. I think this is a good example of that. Also, as the moon goes around the earth, it, with the sun, raises tides. Now, tides are actually beneficial for life on Earth because without the tides, the oceans could risk becoming stagnant. And that would mean life in the oceans would become very difficult, things would die. That would affect the whole food chain, including us. But the moon and the sun raise tides to prevent that from happening. Now, if the moon were much closer to Earth, the tides would start to be destructive to the Earth's coastlines. On the other hand, if it were much farther away, then the tides wouldn't be raised enough and you'd have this stagnant problem. But it's at just the right distance to do what it does well. It's also stabilizing the Earth's orbit. Now, this is something that would only apply over long periods of time, not necessarily relevant in only thousands of years. But I think it's interesting that, as you'll see tonight, a lot of these points are made from people who do believe in the millions and billions of years. Even if you believe in the millions and billions of years, you have to acknowledge that the moon is very important to sustaining life on Earth, because our axial tilt would vary chaotically from 0 to 85 degrees, In other words, we straight up and down and almost all the way over on the side on large timescales, except for the presence of the moon, which stabilizes our planet's rotation. So again, we see, even coming at this from a secular perspective, we have to agree that the moon is uniquely well-suited to support life on Earth. Is that because it's the outcome of random processes, or is that because it's designed? I think it is designed. It was designed to be the lesser light to rule the night, as the Bible says, and indeed it plays that role very well. And since we're mentioning this quote, this brings to mind the other light mentioned in that passage, which is the greater light to rule the day. And that, of course, is our sun. How many people talk about if the sun is intelligently designed? Well, not very many, but when you look at it, there's a lot of evidence for that. For example, the sun is vital for life on Earth. If the sun weren't there, then life here wouldn't be possible. Among other things, it provides warmth for the Earth. Without the sun, the Earth would only be warmed by its interior radioactive decay, which isn't much. It also provides food for us. Plants, of course, require sunlight to grow, and they're the bottom of the food chain. We eat plants, and we also eat things that eat plants. Without the sun doing this, we wouldn't have food to eat. In fact, it also provides oxygen for us to breathe, because the process of photosynthesis, as a result of sunlight in plants, produces oxygen for us here. So the sun has a lot of characteristics that make it look like it was designed to support life on Earth. Of course, an atheist wouldn't agree with that, and let's talk about their view for just a moment. Carl Sagan once said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people." If you pay attention to non-creationary thinkers, you will often see quotes like this, that our sun is nothing special. It's humdrum. We're just tucked away in some forgotten corner of the universe. As this author said, our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity. This author said, our sun, so important to us, is merely an ordinary garden variety star. I could quote other people saying these sorts of things, you've probably seen some of them yourself, but these are wrong. The sun is not at all humdrum, average garden variety. It is not a mediocre star. For example, the sun is brighter than about 90% of all stars in the Milky Way galaxy. Does that sound average? No, not at all. It has more mass than 92% of stars. In fact, if our sun was an average star, it would be a red dwarf, because red dwarfs make up about 75% of all the stars in our galaxy. So if our sun was an average star, it would be one of these. We should be thankful that our sun is not an average star, because life around a red dwarf star would be very difficult. So what is a red dwarf? Well, a red dwarf, as you can gather by the name, is red and small. It's red because it's much cooler than our sun is. And again, this is what a typical star would look like. However, if our sun was a red dwarf star, what would that be like? Well, red dwarfs don't produce a lot of warmth, so to be warm enough, the Earth would have to orbit it very closely. In fact, we'd be orbiting it so closely that the Earth would be in a tidal lock. Tidal lock means the orbiting object is distorted, and the same side always faces the object that it's orbiting. Our moon, for example, always has the same face pointed toward the Earth, right? That's because the moon is tidally locked to the Earth. Well, if our sun was a red dwarf, we'd have to be orbiting it so close that the Earth would be tidally locked to it. That means one side would be perpetually roasting, and the other side would be perpetually freezing. Not good conditions for life to be possible, right? Furthermore, you don't want to be anywhere near a dwarf star in the first place, because these things flare very frequently. They erupt superheated material out into space. They do this so often, they're sometimes called flare stars. Any planet orbiting closely to one of these things when it goes off is roasted. And if life had been possible before, it certainly wouldn't be afterwards. So again, this is what a typical star looks like. Our sun is not a typical star. In fact, even among high-mass stars that aren't red dwarfs, 80% of those are in binary or multiple star systems, where there's 2 or more stars orbiting their common center of mass. And we should be thankful we're not in one of these systems also, because any kind of planet in a multiple star system is sometimes exposed to radiation from more than one star, and sometimes only one. So again, very violent temperature swings on the surface. You don't want that if you're trying to live there. But our sun isn't like that. We live in a single star system. Our sun is a class G star, of which only about 7.5% of all stars are, and even among class G stars, our sun is unique. A while back, a 30-year study was finished of the photosphere, the outer part of the sun, where they were studying the sun's energy output, and they discovered that the sun, over that 30-year period, was constant in temperature. Its variation of energy output varied by less than 1/10 of 1% that whole time. Now, we take that for granted, right? Because we get up, the sun rises, we go about our business. Stars don't do this, though. Even solar-type stars, the stars we can see in our galaxy that are closest to the sun, are not constant in temperature. In fact, studies have shown that even ordinary solar-type stars, the stars that are closest to our sun, have super flares about once every 100 years or so. What is a super flare? Well, you may be familiar with flares on our sun. You see videos like this, perhaps. And these can get fairly dramatic, like this one here. You see a fairly large eruption. Here's the Earth compared to a solar flare from our sun. Now, as dramatic as these are, multiply this by 1 to 10 million times. That's a super flare, which other solar-type stars frequently produce. So again, if our sun was an average star, we would expect it to be producing flares 10 million times greater than what it actually produces. As this author says, sun-like stars normally produce a bright super flare about once a century. But why a super flare has not occurred on the sun in recorded history is unclear. Well, it's not unclear. God created it to support life on Earth. That's why it does that very well, and it doesn't frequently erupt and wipe things out, like these other stars would do. And just for perspective about how violent stars can be, this is the 838 Mon. This star blew up and produced this enormous expanding amount of material. This star here blew up in 2 directions at the same time. There's actually a star in the middle that is producing a dual-lobe explosion. Now, granted, these are unusually violent stars, but my point is, stars are not quiet, stable, calm things. Our sun is, but it's very unique in being that way. As this author said, some of the popular perception of the sun is downright wrong. Writers sometimes tell us that it's just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. This author says, people say the sun is a typical star, but that's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden, places like Earth, where it can exist. And I thought it was interesting that the New York Times is the one invoking the Garden of Eden as a reference here. So we look at this and we can say, does this look random, or does it look designed? I'm arguing that it looks designed because it's unique. It's not average, it's not humdrum, it's not mediocre. Our star was designed for us. What about if we look at the larger scale, out into the galaxy itself? Well, this is interesting as well. Now, for some of these things, points I'm going to make now, they're coming at this from a secular perspective. So they would not apply over only thousands of years, but they would apply over millions of years. And I think it's interesting that the Lord has made things in such a way that even if you try to deny His creative handiwork, you still have to acknowledge that this all looks designed and finely tuned. For example, what kind of galaxy would life be able to form in? Well, you don't want to try to form life in a globular cluster because these are known as dead zones, zones where life cannot form. The stars within them don't have enough metals to supposedly produce planets with the capability of having life. Plus, the stars interact with each other frequently, so any planet would be getting close to some stars and then farther away. Violent temperature swings on the surface, life wouldn't be possible. You also don't want to try to have life in an elliptical galaxy because these two are dead zones for similar reasons as globular clusters. No, if you want to have life, you need a spiral galaxy, which is exactly what our Milky Way is. But you can't be just anywhere, even within a spiral galaxy. You don't want to be the center because that's a dead zone. There's a lot of radiation there, gamma ray bursts and supernova explosions and all sorts of other nasty things happening. But you don't want to be at the edge either because, again, many stars are metal poor. Can't have the scenario where life would form there. No, if you want to be in a spiral galaxy and have life be possible, you want to be right about there. And guess where we are? Right about there. Looking at all of this, again, designed for life, all the perfect conditions for it. In fact, not only is our position in the galaxy perfect for life, notice, by the way, we're in between spiral arms, which reduces the amount of radiation here. We're also in the perfect place to observe the cosmos around us. If we were in the middle of a spiral arm, we'd see bright stars in all directions. You wouldn't be able to see out beyond them. We couldn't perceive the rest of the galaxy we're in. We couldn't perceive the other galaxies beyond them. But our position has us in just the right spot to look outward into the cosmos, learn more about it, and thus perceive more of God's glory through it. Now, there's many more items we could talk about, even coming from the secular perspective. For example, this one book here, again written by secular authors, has talked about all the characteristics you would need to have for a planet to be able to support life. And I don't have the time to talk about all of these, but I will just share with you the amount of material being talked about here. For example, in the solar system, you can't have another Jupiter or Saturn because that would cause orbital irregularities and bad conditions on Earth. You can't have giant planets in eccentric orbits. You can't have hot Jupiters where a Jupiter-sized planet is too close to the Sun. You do need a Jupiter, though. It can't be absent because it protects Earth from impactors coming from space, from outside the solar system. At the same time, it can't be too close, but it also can't be too far. It has to be just right, like Jupiter currently is. And coming at this from the perspective of someone who would believe in evolution, you have all these different things required for life to be possible here. And again, I'm not taking the time to go through each one of these. You'll see why as I go through the list, because there's way too many. All these things are necessary if you're going to have a planet with life to be possible. And I'm not even talking about as finely tuned necessarily as the Earth is. These are just the larger factors that are all necessary. Now, are you going to get all these characteristics as the outcome of a random process, as just the laws of physics move material around according to natural principles? Or do you have to look at all this list of characteristics that are necessary and say, well, maybe a designer was necessary to produce all of this? And this thinking applies not just to the Earth. You could argue, as I'm about to do, that the cosmos itself is finely tuned at all scales, from the very small to the very large. Let's start at the very small. People have looked at the laws of chemistry and particle physics and said, you know, the processes going on, even at that tiny scale, look very finely tuned. For example, this author said this: some super calculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. So this scientist was only studying the carbon atom and found the characteristics it has are so finely tuned that he's attributing it to some super calculating intellect must have gotten involved in this. He says a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to be so overwhelming as to put this conclusion almost beyond question. This is Sir Fred Hoyle, a very prominent astronomer. He's passed away now. He was not a friend of creationism by any stretch of imagination. But even he is admitting a super intellect had to monkey with physics. This author said this, and who this is might surprise you. He said a change of as little as 0.5% in the strength of the strong nuclear force, that's what holds atoms together, or just 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different, and in many cases unsuitable for the development of life. Again, he believes that life developed by itself. I don't accept that. But even coming from his perspective, he has to admit these things. For example, if protons were 0.2% heavier, they would decay to neutrons, destabilizing atoms. And if atoms weren't stable, that would be very bad, seeing as those are the things we're made of. Our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained. It raises the natural question of why it is that way. So who said this? Stephen Hawking. Militant atheist, if you didn't know that about him. So even at the smallest scale, where atoms and particles within atoms are interacting, we see evidence of fine-tuning. We see that going in the opposite direction as well. The entire universe itself has extreme fine-tuning. Even if you don't want to accept creation, you still have to admit this. For example, a few years ago, some people who believe in the Big Bang model were calculating what conditions were like in the early Big Bang universe. Now, I don't believe that the Big Bang happened. They do, though. This is the conclusion they came up with. They realized that the Big Bang model says that the early universe had to be very finely balanced between two opposing elements. On the one hand, gravity is trying to pull everything together. On the other hand, the expansion that's producing the bang is forcing everything apart. They realized that this is walking a real tightrope. If you had a little bit too much matter, gravity would win, everything would collapse into black holes, stars couldn't form, planets couldn't form, life couldn't form, we wouldn't be here to talk about it. On the opposite side, if there was even a little bit less matter, physical stuff, in the early universe, then expansion would win, force everything apart to where galaxies couldn't form, so stars wouldn't form, planets wouldn't form, life couldn't be possible, we wouldn't be here. So if you had a little bit too much matter, or a little bit less matter than we currently have, life wouldn't be here. Everything had to be just right. Well, how much just right did it have to be? They calculated the balance between these two, the margin of error, so to speak, was 1 out of 10 to the 60th power. 10 to the 60th power is 1 with 60 zeros after it. So 1 out of that number is how finely tuned the Big Bang had to be in order for life to be possible today. So that's just a number. What does that mean? Well, here's an illustration. There's about 10 to the 80th power atoms in the universe today. If the Big Bang that supposedly produced all those atoms had to be finely tuned to 10 to the 60th, you can divide that out and realize that the Big Bang had to be precise to within 10 to the 20th atoms of what the universe currently has. 10 to the 20th atoms is about this amount of material in a single grain of sand. Now imagine how big the universe is. All the galaxies, all the stars, everything we see in the sky, and more things beyond those that are difficult to perceive. All this supposedly came from a single event. If that event had made 1 extra grain of sand's worth of stuff anywhere in the universe, everything would have collapsed into black holes and we wouldn't be here. If it had made 1 grain of sand less stuff than what the entire universe currently contains, expansion would have won, galaxies couldn't have formed, life wouldn't be possible. So this random event that supposedly produced all the stuff in the universe had to be finely tuned to within a single grain of sand. Does that sound like a random event to you? And then the problem got worse. The fine-tuning necessary for the Big Bang model is now up to 10, or 1 out of 10 to the 123rd power. That's 1 divided by this number. As this author said, our universe appears surprisingly fine-tuned for life, in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. So again, we're dealing with big numbers here. What does that mean? Well, if there's 10 to the 80th atoms in the universe today, and the Big Bang had to be finely tuned to 10 to the 123rd, now we're down to fine-tuning that's less than a grain of sand. It's less than 1 atom within a grain of sand. is 10 to the minus 43rd of one atom. That's this fraction of the mass energy in a single atom is how finely tuned the Big Bang had to be for us to be here looking at the universe today. This fine-tuning is so extreme that, as this very secular physicist said, this discovery was a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe had to form in such a way to support human life somehow. And you can tell what he thinks of that idea by the adjectives he uses, right? Because what does that imply? It implies there was a creator. So how do we explain all this? Well, there's multiple options. We would argue that the cosmos is designed. It looks finely tuned because there was a fine tuner. Now, of course, the secular folks don't want to accept this, so they have to look for other options. Some people appeal to survivor bias. They say, well, if it hadn't been so finely tuned, we wouldn't be here, so of course we would expect to see a finely tuned universe around us. But this is not an explanation, right? I mean, if you wake up from a deep sleep and you're on an airplane, and you don't remember why you're even there, and you ask the person next to you, why am I on this plane? And you say, well, obviously you're on a plane because if the plane didn't exist, you'd die from lack of oxygen at this altitude. Is that an explanation? No, of course not. So even most secular thinkers don't like this one because it's not explaining anything. Most people today would instead appeal to something called the multiverse. And indeed, this is becoming the consensus solution to the fine-tuning problem. So what is the multiverse? Multiverse refers to there being multiple universes. Now you might be scratching your head right at the gate. How can there be multiple universes if the word universe doesn't mean everything? So how can you have multiple everythings? Well, the word is now being redefined to mean that which we could ever conceivably observe. So even with the best possible technology and so on, it's still conceivable that there's parts of physical reality that we can never observe. Because the universe is expanding too quickly and so light can't get here from there or whatever. So people are now talking about there being an infinite number of universes out there that we can never see. And the collection of these is collectively called the multiverse. So the argument goes like this. With an infinite number of universes, you're going to have various characteristics appear an infinite number of times. Most of those universes, because they were all randomly formed, would look randomly formed, and life wouldn't be possible there. But since there's an infinite number of universes out there, you're going to wind up with a few here and there that just happen to have the perfect combination of characteristics to support life. We just happen to live in one of those. And indeed, the Big Bang model now incorporates this idea, and the early inflationary period of the Big Bang supposedly produced infinite number of universes that are constantly bubbling off. It's been going on for eternity and will continue to go on for eternity forever. We're on to mic number 3 now. So the explanation for fine-tuning is this. There's an infinite number of universes out there. And again, these are part of the Big Bang model now for most secular thinkers. And so that explains why our universe just happens to be so finely tuned. Not because there's a fine-tuner, but because there's an infinite number, and so you're going to wind up with this combination of characteristics somewhere. And we just happen to be in one of those universes. As this article says, is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities in a solar system, just like this one. The life of this person has been identical to yours in every respect. What are they talking about here? This is an implication of the multiverse. If there's an infinite number of universes out there, then every possible combination of characteristics has happened an infinite number of times. That means there's an infinite number of universes out there where we are having the same presentation tonight. There's an infinite number of universes where we're having the same presentation tonight, but there's a slight difference compared to this universe. Maybe you had something different for breakfast this morning. There's an infinite number of universes where the South won the Civil War. There's an infinite number where there never was a Civil War because the 13 colonies lost their revolution against King George III. On and on it goes. Every possible history you can think of is out there an infinite number of times. Question number 1. If there's an infinite number of copies of you scattered throughout physical reality, how valuable are you as a person now? Not very, right? There's an infinite number just like you. The article continues, you probably find this idea strange and implausible, yet it looks like we'll just have to live with it, since the simplest and most popular cosmological today predicts that this person, the other copy of you, actually exists in a faraway galaxy. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. Remember this phrase, we're going to come back to this. In the multiverse, even the most unlikely things will be out there an infinite number of times. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many with people, with the same appearance, name, and memories as you. They are you, infinite copies of you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. So again, under this idea, which is mainstream now in cosmology, even the most unlikely events must take place somewhere. And as an illustration of how mainstream this is, you can go buy books from multiple scientists talking about this. Talking about all these universes that no one will ever be able to observe. Is that science? I don't think so. This author said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like you can supersize or not, says this theoretical physicist. Our cosmological history, he says, tells us that it's there, and we need to deal with it. So even if this idea seems strange to you, you need to just deal with it, because this is science, or so they say. But is it really? What's the one thing we know about all these other universes? They're unobservable by definition. That's what makes them other universes, right? So they're outside of the natural world that we can observe. What word did we use to describe something that's outside of the natural world? Supernatural. That's what the word means, right? So we're not allowed to talk about creation because that's invoking a supernatural cause. Yet they're invoking supernatural explanations, an infinite number of them, in fact. Is this consistent? Even some secular authors are unhappy with this. This author said, these multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. There's no test and no observation you can run to see if they're there or not. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. This author complains that multiverse is really just pseudoscience. But it's not just outside of science, and it's even beyond bad science. Multiverse, when you think about it, is really absurd. You can use it to prove all sorts of things that the secular proponents of it don't necessarily intend. For example, let's say you can have some fun with this even. Let's say you're talking to an atheist, and he's a fan of someone like Richard Dawkins. So you can ask him, did you read Professor Dawkins' book, The God Delusion? He'll probably say yes, because this is a bestseller. Well, in that book, Professor Dawkins said there almost certainly is no God. Do you believe that, Mr. Atheist? Well, yes, that's why I'm an atheist. Okay. Let me reword that a little bit, and tell me if you still agree. It is most unlikely that the God of the Bible exists. Do you agree with that statement? And he'll probably say yes. Well, that's interesting, Mr. Atheist, because a moment ago you told me about the multiverse to explain fine-tuning. Now you're telling me it's most unlikely that the God of the Bible exists, but in the multiverse, even the most unlikely things must be true somewhere. Therefore, the God of the Bible exists. Right? Taking this thing into its logical conclusion. In fact, this is a valid biblical approach. The Bible says you shall know them by their fruits. If the multiverse were a good scientific approach, a good scientific model, then it would have good scientific fruit. Conversely, if it were a bad scientific model, or even absurd, it would produce bad fruit. So let's look at the logical implications of the multiverse idea and ask, is this really science, or is it just science fiction? Now, we've already said that in the multiverse there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. Well, what does that mean? That means, among other things, Captain Kirk and Mr. Spock are real people. Right? Every possible cosmic history is true somewhere out there. There's an infinite number of places where every episode of Star Trek is real. Even the really painfully cheesy ones. But even the most unlikely events must take place somewhere, right? Another author wasn't talking about the multiverse specifically, but the same logic holds true. He was talking about exploring further out into the cosmos and what happens if you run across planets that still have dinosaurs on them. He said, well, on Earth, dinosaurs went away because they got wiped out by a freak asteroid collision. I don't believe that either, but he does. But what about these other planets where dinosaurs evolved? They didn't have a freak thing kill them. They would have time to evolve further. In fact, these life forms could well be advanced versions of dinosaurs. We'd be better off not meeting them. Well, that's true, because there's nothing worse than running into a dinosaur that has better weapons than you do. Right? Now you're laughing, but if the multiverse is real, this is real. Now, is this science? Or just science fiction? Well, the multiverse says that there's an infinite number of planets out there where humans are fighting advanced dinosaurs right at this moment.
Look out! There comes another one!
Now, obviously I'm having fun with this, but if the multiverse is real, that's a documentary. Other people have taken a little bit different approach to this. They said, okay, well, the multiverse isn't necessarily why our universe looks so finely tuned. Instead, it is proposed that our universe was created by life and superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. This explains why the constants of physics have their observed finely tuned values, and might even help us to understand why our universe is comprehensible to the human mind. So that's why the universe looks designed. Not because God did it, but because aliens did it. But is this science? Or is it just science fiction? Other authors are taking a different approach still. This one said, in perfect seriousness, by the way, it's a perfectly acceptable supposition that the world as we know it is a vast computer program run on machines built by an intelligence we know nothing about, in a universe that could be like any of the ones we speculate about, or one that's totally strange and alien. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes, there would in all probability be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of the universe. Why are they saying that? Well, here's their thinking. First of all, if you believe in the Big Bang, then the Big Bang supposedly made everything. But what could the Big Bang have made? At best, with matter, energy, space, and time. Material things and physical things. Notice that there's nothing immaterial in there. Where does consciousness fit into those four things? Is consciousness made of matter, or energy, or space or time? No. Their conclusion then is that, well, consciousness must just spontaneously arise out of physical stuff. Therefore, it's possible to simulate a universe in which conscious beings are within. Now let's do a little bit of math without actually using numbers. Our civilization has had computers for decades now. How many simulations have we run during that time? Some large number, right? Let's call it 1 billion, just to pick a number out of the air. So there's been 1 billion simulations per one actual universe that's making them. Now what happens if in the multiverse an alien civilization gets such good technology that they can simulate entire universes inside their computers? They will eventually produce billions and billions and billions of simulated universes compared to the one actual universe that made them. Everybody still with me? So if you look in the sky and say, we live in a universe, if there's billions of simulated universes compared to one real one, what are the odds that you're in the real one? 1 out of the billions. Conversely, it's billions to one that you live in a simulation. So the logical outcome of this type of thinking is that, yes, the math says we probably live in a computer simulation. So you might think we live in a real universe, on a real planet called Earth, in a real solar system, a real galaxy, all the rest of it, but that's not true, because what's really happening is we're just living in a video game being played by some alien somewhere. Now, you might think this sounds rather silly, but there are scientists seriously studying this idea, and using our tax dollars to do it, by the way. Isn't that good news? Do we live in a computer simulation? These people are actually studying this idea. But there's other implications here. Let's think about this. If aliens could make such good technology that they could simulate entire universes, they could also simulate universes that contain aliens that can simulate universes. Right? And that's what this author says. There could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. And he's serious about this, by the way. So it's not only that we live in a video game being played by some aliens, they themselves are living in a video game being played by some other aliens. But then why stop there? Maybe they're living in a video game being played by some other group of aliens, who are in a video game being played by some other aliens, who are in a video game being played by, well, you get the idea. Is this science? No. This isn't even science fiction anymore. This is just absurdity, right? But it's the logical conclusion of the multiverse. This logically follows once you grant that the multiverse is true. Or once you accept it, I should say. I don't grant that it is. But these are intelligent men and women promoting these ideas. Why? Why are intelligent people promoting an idea that has absurd implications? Here's why. If there's only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. The Bible says that the fool has said in his heart, there is no God. Now, don't get me wrong, I'm not saying these people are fools or stupid. Again, these are very intelligent men and women. But they're promoting a model that is foolish. Why is that? Because the fear of the Lord is the beginning of wisdom. If you deny the truth, then whatever it is you wind up believing has to be a lie, right? If you start your thinking of your cosmological model on a denial of wisdom, then whatever it is you wind up believing, whatever model you wind up building, is going to be foolishness. So what's really happening here? Our society likes to say things like, well, science disproves the Bible, that's why scientists reject God. That's not what's happening. Scientists are rejecting God first in their thinking. Therefore, they claim that science disproves the Bible, regardless of how absurd or impossible their models become. This is not a battle of religion versus science. The science is on our side, not theirs. Because indeed our cosmos is finely tuned, not because there's a multiverse, but because it's designed by a designer. The heavens do not declare the glory of the multiverse, the heavens declare the glory of God, and the firmament shows the work of his hands. And indeed they declare his glory in ways we can't possibly comprehend. But it is our joy and privilege to be able to look out in the cosmos and catch even a glimpse of the glory of our Creator through it. So that's the end of my presentation here tonight. Couple more items. Judy mentioned that website, creationastronomy.com. On that site, I have a free email newsletter. You can sign up for it there. You won't get bombarded with spam. Currently, it's only a couple issues per year. But if you like this perspective on astronomy that you've got tonight, you can probably guess you won't get this very many places. That's available to you. Also on the back table, there's a set of 3 DVDs. A lot of what I talked about tonight appears in these DVDs and these videos. Volume 1 of the series is all about the solar system. It goes planet by planet through the solar system. Talks about all the terrestrial planets, all the gas giant planets. Talks about where do these things come from. Did they come from a gas cloud, operating according to laws of physics? Or does it appear that they came from a creator? I talked not only about the planets, but also about a lot of the moons and other objects as well. Volume 2 in that series is about stars and galaxies. Where did they come from? What can they tell us about origins? You heard a little bit of that tonight with the sun being designed, but it also gets into the origin of stars, the origin of galaxies, and so on. It talks about what our cosmos tells us about our Creator. Volume 3 is about the Big Bang model and the origin of everything, the origin of the universe itself. Is there evidence for a Big Bang? You probably already know my answer to that question. The Big Bang model is not really bad science, it's actually anti-science. The multiverse is in there, along with other things that I didn't have time to talk about tonight, finally the universe and so on. So the DVDs are available tonight for purchase. If you'd rather have digital copies instead, those are available on the site here. I don't currently have ways to offer digital videos in a physical format. But they are less expensive than the DVDs, incidentally. And there's another benefit too, they're higher resolution than the DVDs can be, because DVDs are limited in what they can do. And as a third bonus, as I update these videos, you get all subsequent updates for free. So if you're undecided about physical DVDs versus digital, go with the digital. But you'd have to buy that through the site. I don't know if those for sale tonight. So that brings me to the end of my presentation. I understand we're having questions now.
Yes, let's thank Spike.
Thank you.
So we're going to go ahead and take questions and answers. We are live streaming, so Spike, could you repeat the question?
Sure.
For the
If I
folks
forget,
on the
I
live
promise.
stream? Okay. Okay, do we have any questions? Don?
Okay, I'm a little confused about, I realize it's nonsense, but the whole multiverse thing, the reason they go to that, is it not because ours is so super fine-tuned that there's no real explanation for that? So there must be a whole bunch of them, the rest of which aren't quite so finely tuned, but then ours is finely tuned. But then they jump from that to there's an infinite number of them that are finely tuned, and there's a bunch of me's everywhere through the universe. So it's just like, where are they going? I don't get it.
Yeah, where are they going with the multiverse? I'm not sure there's an answer to that question. Because once you say there's an infinite number, then the rest of it kind of follows. With an infinite number of anything, you can have all possible values an infinite number of times. Which is why there's infinite copies of us, according to this idea. There's an infinite number where this presentation happened yesterday, because those universes are farther ahead in time than we are. Or where this hasn't happened yet, and so on. Any possible thing you can think of is out there an infinite number of times. That's one of the points I was emphasizing. That's not, they didn't necessarily, that wasn't their goal to push the implication of that. A large part of the thinking was to explain away the fine-tuning. That with a large enough sample size, even in the unusual values will be out there a sufficient number of times to account for some finely tuned ones existing without having to invoke a fine-tuning.
All right, so given that it's infinity, we have a greater infinity of non-finely tuned universes, but there's still an infinite number of finely tuned universes.
Right. Yeah, given an infinite number, there'll be many more that aren't finely tuned compared to the ones that are, yes. That's true.
Yeah, what's the precision level for like our atmosphere has to be so that's perfect so water doesn't steam away or water freezes?
What's the precision of our atmosphere so that water can be retained and not boil away or freeze? That's a good question. A lot of that depends on climate modeling and how a greenhouse effect works. And it used to be thought to be fairly straightforward, but as people have studied this, it's not necessarily as easy to calculate as people thought. This is one of the reasons that there's a controversy over the climate change issue. People are saying that even small amounts of greenhouse gases will kick us into a runaway greenhouse effect. Other people are saying, well, that's not necessarily true. So I don't know the answer to your question. I'm not sure anybody does, because they're still arguing over some of the things that would produce the number that you're asking about. Does that make sense?
Other questions?
No. I showed you a dinosaur driving a tank and no one's even... Yes, sir.
So I guess the sun is basically made up of hydrogen gas, is that correct?
The sun is mostly hydrogen gas, yes. Most stars are.
So where does the hydrogen gas come from?
The secular view would say hydrogen was the bulk of what the Big Bang made. I'm sorry, the question was where did the hydrogen come from? The Big Bang supposedly made a lot of energy which cooled into matter, and then the matter formed mostly into hydrogen, because it's the simplest structure of an atom. You have some helium and a little bit of lithium, and that's about it. So the Big Bang could make the simplest atoms according to the Big Bang model. And those are the things that stars were subsequently made up of, because that's what was available to make stars from. Does that answer your question?
Yeah, pretty much. And then the nebulae, that's all hydrogen gas as well?
Now, nebula are a combination of things. Now, remember, if you're a Big Bang thinker, you think that you're looking at a universe that's 14 billion years after it began. So at the very beginning, there could only have been hydrogen, helium, and a little bit of lithium, etc. But subsequently, stars formed, nuclear fusion happened, new elements were formed, and so on. So the universe today isn't limited to only what the Big Bang could make, or could have made. So we see other things in the universe today that did not come directly from the Big Bang, supposedly. Hope that answers your question. Yes? What is a planet made of? That's a good question. It depends what planet you're asking about. The 4 planets closest to the sun are mostly made out of rock, like the Earth is. So the Earth is mostly made of rock, and so are Mercury, Venus, and Mars. But beyond, farther away from the sun than Mars is, you have Jupiter, Saturn, Uranus, and Neptune. Jupiter and Saturn are mostly made out of gas, and then Uranus and Neptune are gas and ice. So different planets are made out of different things. Yes, ma'am?
On your DVDs, you mentioned that you were considering doing that before. What about your, is that still on your docket?
It's still, the question was, on my first DVD, I mentioned that there was a later video coming on age issues related to the Earth. That is still planned, but it's not going to be the forefront. Since you asked. Volume 1 is currently being revised and updated. That'll be out, we're rolling here soon. Bringing some of the material up to date, talking about Pluto, which the original one did not because we haven't been there yet. Volume 4 is then next on the list. That's going to be on the distant starlight issue. How can we see stars that are so far away it should have taken millions of years for light to get here in a young universe? Volume 5, maybe I shouldn't be revealing all this in the live stream. Volume 5 is supposed to be about alien solar systems. We're discovering a lot of planets outside of our own solar system. There's some really cool stuff happening there and causing all sorts of consternation among people trying to account for ours. The video you're asking about on age issues will probably be outside of the current series because it's not only about astronomy, it's going to be involving geology and some other things as well. So because it's outside of the series, I want to finish the series first at 5 volumes and then get to that. And then hopefully do some more on other topics after that. Yes, sir?
Does your creation effort get into life itself? You're talking here planets and non-living things. Are you moving into life itself? Science has never been able to create life by mixing chemicals together. You have to have life to start with in order to create life. How do they explain that? Don't know.
So the question is about the origin of life itself. I personally will not be talking about that. You would need like a biochemist to do that, which I am not. However, I've accumulated a large amount of material on how life works, which is kind of related to the question, how where it came from. But as we're, for example, as we're learning more about DNA and how DNA works, there's computer science principles built into it. There's a lot of things that as an engineer I see that a biologist might not because a biologist doesn't have engineering training. And there's people in the creation movement now who are talking about cross-pollinating, so to speak, collaborating, and bringing different areas of background into this to talk about this. As an example, this is kind of an aside. I went to a genetics lecture once, and the lecturer was talking about how all this stuff worked, and my mouth was hanging open, and so was some other people. And he noticed that he said, I like giving this talk to engineers, because you guys understand what we're talking about here. I give this talk to biology students, and they just say, oh, it's just a bunch of goo doing what goo does. He said, no, this is software engineering at work here. And he said, I think every biology student should be required to take a semester of computer science to really understand what we're seeing in the cell. So if I ever do cover those sorts of topics, it'll be from that perspective rather than just the chemistry of how it could have formed or could not have formed, because that's I'm not the person to talk about that. Yes, sir.
You made the transition from being a atheist to a creationist to a Christian. Can you tell us a little bit about that in a couple minutes?
How did I make a transition from atheist to creationist and Christian? Without dwelling too much on personal stories, I'm less interested in talking about me and more interested in talking about creation itself. I can tell you what question really got my interest and started me down this path. And I think this can be useful to people in talking to a non-believer like I used to be, because some people will have problems answering this question, as I did, in led me where I am today. Where did the universe come from? It's the biggest question, right? Why are we here? How did we get here? Well, as I mentioned earlier, the standard model is that there's a Big Bang, which produced everything, etc. But without doubt, a lot of people don't feel qualified to discuss the details of secular cosmology with other people, because these are complicated models. But you don't really have to know the details of the model to really get good conversations going. If there's one thing I'd like you to take away from the talk tonight, it's this right here, because this will probably be the most useful to you in talking to other people. There's a 6-word question I'd like to ask. Did the universe have a beginning? This question was asked to me, and that's what started me on the journey to where I am now. Because this question I now call the secular dilemma. Did the universe have a beginning? How many possible answers are there to that question? 2, right? Yes or no. Either yes, the universe had a beginning, or no, there was no beginning, which means it's been there forever because it never began. Therefore, it's eternal, right? Do we all agree that those are your only 2 options to answer that question? This isn't a trick question, by the way. I call this the secular dilemma because if you approach this question from a secular perspective, you have to pick one of the 2 answers. Both of them will violate physics, though, if you're coming at this as a secular thinker. What do I mean by that? Well, let's talk about the first answer. Yes, there was a beginning. If the universe had a beginning, then what could have existed before that beginning? Nothing, right? Because if there was something before the beginning, then whatever began wasn't the universe, right? Because the universe is everything. So if everything had a beginning, there could have been nothing before that beginning. Everyone still with me? That means, ultimately, that something had to come from nothing. Here's a graphic of what the universe looked like before that beginning. But does that work? Can you go from nothing to everything? Can you go from nothing to anything? No, because nothing can create nothing. Nothing can do what? Nothing. From nothing comes nothing. Now, so far this is more of a philosophical approach, right? But physics actually is based on a principle called the conservation of mass energy that formalizes that idea. You can't have something coming from nothing. This principle says, how much time do I have?
It's okay, go ahead.
Okay. I go on random. But anyway, a fundamental principle of physics is called called the conservation of mass energy. The total amount of mass and energy in the universe is conserved, meaning it never changes. Sometimes this is called the first law of thermodynamics. Now you can change one to the other, but you can't produce either one from nothing. What do I mean by change one to the other? Well, physics now understands, you might have heard this equation E equals mc squared. Matter and energy can be converted back and forth. So we can convert matter to energy, for example. The most efficient way we know how to do that is a nuclear bomb. A little bit of stuff converts into a large amount of energy. But did the energy come from nothing? No, you needed the stuff first, right? You needed the bomb. You can go the other direction and take energy and turn it into matter. We do that in particle accelerators. You take little chunks of stuff and get them, zip it around close to the speed of light, smash it together. More stuff comes out of the collision than went in. Not just number of particles, but the amount of matter, the amount of stuff. But are we making the stuff from nothing? No. We're converting the kinetic energy, the energy of motion, into the physical stuff. So you can convert matter to energy, you can convert energy to matter. You can never make either one from nothing because that violates physics. And we see this principle in our lives every day. I mean, think about this. Why do you need to eat food? Despite how difficult that process might be. Because you need energy for your body to work. Can't get it from nothing because that would violate physics. So you need to get it from the chemical energy stored in the food. Assuming you can actually get it in your mouth first. Why do you get a bill from the power company every month? Because your appliances need energy to work. Can't get it from nothing. That violates physics. So you have to get it from the power company. Which also can't get it from nothing because that violates physics. It has to get it from the chemical energy stored in coal, or the gravitational potential energy in flowing water, or solar energy from the sun, which also can't make energy from nothing. That violates physics. It's burning hydrogen, like we talked about earlier, and so on. Endless examples of this. Point is, you can't make something from nothing. That violates physics. That therefore implies that the universe could not have had a beginning. Well, if there's only two answers and the first one can't be true, let's talk about the second one. The universe has to be eternal then, right? But can it? Does the universe we see look eternal? No, it doesn't. That's because of a different law of physics called the second law of thermodynamics. What does that mean? Well, here's a simple example. If you walk into the room and there's a hot cup of coffee on the table, how long has it been there? A long time or a short time? Short time. Why? Because it's still hot. It hasn't cooled off yet. Second law of thermodynamics, among other implications, says hot things cool off over time. So we can use coffee as a crude form of clock, right? It's not very precise, but it gives us big answers. We can apply the same reasoning to the universe. Actually, back up a minute. Could hot coffee have been there forever? No, because if it had been there forever, it would have cooled off forever ago, right? Now let's use the same logic and apply to the universe. Is there anything in the universe that hasn't cooled off yet? Stars? Wait long enough, every star eventually runs out of fuel and cools off, or blows up before that happens. Either way, they're not there anymore. So if the universe were eternally old, would we still see stars today? No. They'd have been gone eternally long ago. Still with me? Now some people argue, well, new stars can form to replace the old ones. There's problems with that without a creator. But let's set that aside. Star formation would still require energy. It consumes energy, of which there's a finite amount, so that would have been gone eternally long ago too. So if the universe were eternally old, what would we see in the sky? Nothing. Stars would be gone. The fact that we do still see stars tells us the universe is not eternally old. And if it's not eternally old, it had a what? Beginning. There are ministries out there teaching people that Christians need the Big Bang model to prove that the universe had a beginning. But first of all, the Big Bang model doesn't match what Genesis says. Number two, we don't need the Big Bang model to prove the universe had a beginning. You want to prove the universe had a beginning? Go outside and look up. You see stars? Or the sun? If so, the universe is not eternally old, therefore it had a beginning. It's a daily reminder of that. Back to our dilemma. We already saw that first law of thermodynamics, the conservation of mass energy, does not allow the universe to have a beginning. Now we see that it also can't be eternally old. What's the only way out of the trap? A supernatural creator made the universe. Yes, it's not eternally old. We know that because there's still stars, so therefore it had a beginning. But in order to not violate physics, you need a supernatural creator outside of physics to account for the universe. So, as Christians, we have a model of origins that is consistent with the laws of physics. If you deny a creator, though, you don't have that option. You can only pick one of these two choices, both of which violate physics in a different way. Does that make sense to everyone? So if you're talking to an unbeliever and you're looking for a conversation starter, different people have different interests. This may not appeal to everyone, but some people will be really intrigued by thinking through the implications of that. This is how I got started doing all of this, was trying to find a way out of this trap. A way that I could still be an atheist and believe the laws of physics all at the same time. But I eventually realized I had to make a choice. As a Christian, I can embrace physics in my model and have it be consistent with my model of origins. But a secular thinker doesn't have that. All secular models must violate physics. And notice this isn't just a Big Bang thing, by the way. Any secular cosmology has this problem. The only explanation that's consistent with all of physics is a supernatural creator. So that probably wasn't quite what you were asking for, if that question. But hopefully that's a more practical answer than just me talking about myself. Thank you everyone for your attention. And I'll see you in a few minutes at the back table if you have any more questions. Thanks.